In this video, we'll be going through composite functions, how to find composite functions and how to find functions from composite functions. Let's start with some of the basics that you will need to know about functions to learn composite function. So what is a function relating set x to set y? A function, this function is a special relation where each element in set x is mapped to, this is the term that we use, mapped to one and only one element in set y. This is very important. So all we need to know for this video is, let's say you have function f that maps all the elements in set x to all the elements in set y. So let's say we have two different set of values, and the function f is the function that maps each element in x to one element in y. This is called an arrow diagram. So let's say y is equals to x plus 2. This would mean that if we had an element 1 in set x, the function f would map 1 to 1 plus 2. So that would be 3. So x plus 2 is the image. So this is known as the object. This is the object. And this is called the image. So let's use set notation for this. We can write down this function as the function f maps x to y. We could also write it down as the function f maps x to x plus 2. And another way that we use this is in equation form. So we could say that f of x is equals to y, or f of x is equals to x plus 2. And all the values of the object, so let's say we have another two objects. Let's say we had 2. Function f would map 2 to 2 plus 2, which is 4, and 3 to 3 plus 2, which is 5. So this set of objects here, this is known as the domain. All the possible values for the object of the function is known as the domain. This is all you need to know in order to learn composite functions. So what is a composite function? A composite function is simply a combination of two functions. We also call this composition of functions. Combination or composition of two functions. Now let's say we had two functions. We start with set x again. This set of values, set x. And then we have another set of values. Let's call it set y. So let's say the function f maps x to y. This is the function f. Here we say that f maps x to y. So let's say I have another set of values, z. And let's say another function, let's call it g. G is a function that maps y to z. So we can say that g maps y to z. Notice that the domain is different here. X is the domain for the function f, whereas y is the domain for the function g. So what if I wanted to go directly from x to z? So this is where we have to do composition of functions. We have to combine the two functions together, f and g. So now the question is, will this composite function become fg or gf? Now let's look at this very carefully. When x is mapped to y, we say that f of x is equals to y. In other words, this is also f of x. And so what we are actually doing is, we are taking f of x as the domain of the function g. And so in order to arrive at z, what we are actually doing is, we are doing g of y is actually g of y equals to z. But now what is y? Y is f of x. Therefore, what we are actually doing is g of f of x is equals to z. So when we combine the functions, what we are actually getting is gf of x. This is how we define the function, the composite function gf. Gf is actually g of f of x. And so this function, this composite function, would be gf and not fg. Notice here also the x. This x is actually the same x which is the domain of f, not g. So x, this x which is the domain of f, is also the domain for the function gf. Let's try an example. So let's say we have two functions, f of x and g of x. So f of x is 3x minus 1. That is to say, the function f maps x to 3x minus 1. So this is the function f. Okay. Then we have g of x. So let's draw another arrow diagram. So we have g of x which maps x to 2x squared plus x. So this is g of x. Now notice that this x, the first x, this one, is the domain of f, and this x is the domain of g. Now they are not the same. This x and this x are not the same. So when we want to do a composite function, let's say we want to do, let's try gf of x. So gf of x is defined as g of f of x, as we did earlier. So what does this mean? We are taking f of x as the object that is put into the function g. So how do we do that? Look at the function g. We are taking x and we are putting f of x as x. That means all the values of x will be substituted with the object f of x. So this will be equals to 2. X will be f of x. So wherever there is x, we are going to insert 3x minus 1. So this will be 2 3x minus 1 squared plus 3x minus 1. So this will be the composition of g and f into the function gf. So remember, this x is the domain of the function f. So let's do this. So this will be equals to, we just have to simplify this. So we just expand this out. So this will be 2. This will be 9x squared minus 6x plus 1. And then this will be plus 3x minus 1. And so you just continue to work this out. And the final answer is 18x squared minus 9x plus 1. So let's draw this in the diagram to be very clear. So what has happened here is we have started with, again, we are starting with f because we are starting with the object x, which is the domain for the function f. So we start with the set that contains x, and then the function f maps x to f of x. So this is the next set, and then the function g maps f of x onto g f of x. So this is the last function. The composite function here, x, is gf. Gf is the function that maps x to gf of x. By the way guys, if you're getting value from this video, please do me a favor and hit that like button. It really does help the channel a lot. Thank you very much for doing that. Let's continue. So let's say we wanted to find the other way around. Let's say we wanted to find fg of x. So what is fg of x? Fg of x can be defined as f of g of x. So now g of x is acting as the object that is going through the function f. So we are going to map g of x using the function f. So what we do here is we look at the function f, where the object, this x, is going to be g of x. So wherever there is an x, we're going to insert g of x as the object, which means fg of x will be equals to 3. Now, wherever there is x, we're going to insert 2x squared plus x minus 1. And so we just have to work this out. This will be 6x squared plus 3x minus 1. So how do we use this composite function? Let's say I have an object that is 1. So where is 1? 1 will be the object in this set because x is the domain of f, the function f. And so here, let's say I wanted to find what this would become here. So the long way to go about this will be, we first find f of 1. So since f of x is 3x minus 1, f of 1 will be 3 times 1 minus 1. And this will be equals to 2. So this will be the image under the function f. And then we have to find what is g of 2. So now we are going to put 2 into function g. So g of 2. First we look at g of x. G of x is 2x squared plus x, which means this will be 2 times 2 squared plus 2. So this will be 10. So this is the long way. We do one by one. First we put it into function f, and then we put that image as the object into function g. Or we could straight away use gf. So let's say we put the object 1 straight away into the composite function gf. That would mean we are looking for gf of 1. Now this will be equals to 18 times 1 squared minus 9 times 1 plus 1. So that will be 18 minus 9, which is 9 plus 1, which is 10. So this is how a composite function works. Now let's look at how to determine a function when the composite function and one of the functions are given. So we're trying to determine the other function. Now there are two scenarios here. First, let's say the function is on the so-called inside. This is not a proper term. So let's say we have fg of x and you want to find the function g. So g is so-called on the inside. So how do we do this? First, let's define fg of x. So fg of x is equals to negative 5 minus x squared. So this can also be defined as f of g of x. F of g of x is equals to negative 5 minus x squared. Now keep in mind, as we did earlier, as we established earlier, this x is both the domain of fg and the function g. So they are the same. So this x is the same as this x. So all I need to do here is, I need to use g of x as the object that is put into the function f. So we are given the function f. All I need to do is use g of x as x. So this will be g of x minus 7 is equals to negative 5 minus x squared. So what I've done here is I've taken g of x and I've put it into here as the object of the function f. And now we can find g of x. Therefore, g of x will be equals to, we just add 7 on both sides, plus 7 plus 7. So this will become negative x squared plus 2. Negative 5 plus 7 is 2. So this is how we find the function which is on the so-called inside. Now this is the easy one. Now what if the function was on the so-called outside? So for example, they've given g of x and they've given fg of x. They want you to find the function f. Now you can see the function f is on the so-called outside. How do we find this? So let's try to do the same thing. Let's define fg of x first. So fg of x is equals to x squared minus 2x. Now we can define fg of x as f of g of x, which is equals to x squared minus 2x. Now in the earlier example, we were given the function f. This time we are given the function g. So f of g of x. What is g of x? G of x is 5 plus x. So f of 5 plus x is equals to x squared minus 2x. Now you have to be careful because it's very tempting to think that we need to substitute x with 5 plus x, but that is not the case. Let me show you what this means in an arrow diagram. So f g of x, so we have two sets. We have three sets of data. So we start with x. So let's start with x here. For f g of x, this is x is the domain for the function g. That means we go through the function g first. So g is the function that maps x to g of x, which is, so this is g of x. So this time we are given g of x, which is 5 plus x. And then what the function f does is, the function f is mapping g of x, which is 5 plus x. So this is the function f will map g of x to f g of x, which is, here it's given to us as well. F g of x is this, x squared minus 2x. So this is x squared minus 2x. So now we want to find what is the function f. As it is, we cannot find the function f in its own domain. We are looking at the function f with 5 plus x as the domain. And x here, remember x is actually the domain of g. So what we are doing here is actually we are defining f in terms of the domain of g, which is not what we want. What we want is to define f in terms of its own domain. So therefore, what we are going to do here is we are going to say let the domain of f be y. So that means we are saying that let's give f its own domain. Let 5 plus x be equals to y. We want to express f in terms of its own domain, which means what we want to find is f of y. This is what we want to find. How do we do this? If we want to find f of y, what we have now is f of 5 plus x. From here, since we said let 5 plus x be y, we can say that f of y is equals to x squared minus 2x. X is, remember, x is the domain of the function g. X is the domain of g. What we want to do is, we want to express f of y in terms of y, in terms of its own domain. So what do? We substitute x, wherever we have x, we substitute it in terms of y. That means we have to find x in terms of y. So we can do that from here. From here, we can say that x is actually equals to y minus 5. And so now we can define it in terms of y. So f of y will be equals to y minus 5 square minus 2 of y minus 5. So you can see what we've done here. We've effectively removed x from the equation. So now all we have is the function f defined in terms of y, in terms of its own domain. So now we just have to work this out. F of y will equals to y squared minus 10y plus 25 minus 2y plus 10. Y squared minus 12y plus 35. So when we define functions, we usually put the object as x. We usually describe the object as x, not as y. And so when we are defining f as a separate function, we can say that the function f would map x to x squared minus 12x plus 35. So note that this x is not the same as this x. This x is not the same as this x as well. This x is the domain of G. Whereas now we are defining f as a separate function, no longer as part of the composite function. So on its own, the function f would map x, object x, to x squared minus 12x plus 35. If you haven't already guys, please do help me hit that like button if this video has helped. See you guys in the next one.